Okay, to evaluate a function for the given values, we take f of the number, which for the first example is 1. We plug it in for x. So instead of x plus 3, we would put 1 plus 3 minus 4. And then to solve that, 1 plus 3 is 4. The absolute value is 4. And so 4 minus 4 would be 0. And then we'll do the same thing for negative 3. Now be careful when you have a negative in here, you solve before you do the absolute value. So negative 3 plus 3 is 0. The absolute value is still 0. Minus 4 would be negative 4. Then we'll do it with negative 5. Negative 5 plus 3 is negative 2. The absolute value is 2. Minus 4 would equal negative 2. Okay, the braces around the x is something you probably haven't seen before, and it's something called the greatest integer. So 3, and then we substitute negative 1.5. Negative 1.5 is not an integer. So we're going to think about our number line here. Negative 1.5 would fall in between negative 1 and negative 5. So the greatest integer means we need the integer less than or equal to x. In order to go less than, we need to go left on the number line. So the next integer to the left of negative 1.5 would be negative 2. So we actually need 3 times negative 2, which is negative 6. Okay, and then 3 to 1/2. 1/2 would be right here. So the integer to the left of that would be 0. 3 times 0 would equal 0. And then 5/4. That would be 1 and a fourth. So that would be about right here. And the integer to the left of that would be 1. And then 3 times 1 is 3. Okay, to graph an absolute value function, you want to first look for your vertex and then do an XY table from there. So your vertex you can find using H and K. It should have been a K, not a 3. So HK is your vertex. So in this case, we don't have anything added in here, so 0 and then K is 3. So that's my vertex. So on the XY table, I want 0, 3 in the middle. And then I'm going to pick 2 points before and 2 points after. So if I plug in negative 2, absolute value negative 2 is 2, plus 3 is 5. With negative 1, absolute value is 1, plus 3 is 4. With 1, absolute value is 1, plus 3 is 4. And with 2, absolute value is 2, plus 3 is 5. Notice the pattern we have here. This is a symmetric, and it's actually going to make a V. So now we can plot these points. If x is negative 2, y is 5. And if x is negative 1, y is 4, 0, 3, 1, 4, 2, 5. And it's going to keep on going with that pattern. Notice it makes a V. All of these absolute values will make a V. And our vertex is this point right here where the direction of the line changes. And this is a type of piece function because it has 2 pieces. It has 2 lines or rays actually joining together at a point. Now the domain of this graph, our domain is x values, and notice it keeps going out It's going to continue to hit all of your x values. So your domain would be all real numbers. And then your range, notice you have a bottom point right here, but it keeps going up from there. So that point, y is 1, 2, 3. So y is greater than or equal to 3. Because it's a closed circle, we include the equal part. Okay, here's another type of piece function. For each piece, it gives us a domain. So for the first piece here, it says f of x, or y, equals 2 if x is less than or equal to negative 8. So that one point there would be negative 8, y is 2. If y is anything, or if x is anything less than negative 8, say negative 9, then y is still 2. If it's, say, negative 10, y is 2. So all of these, so where y is 2, start where x is negative 8. So 1, 2, 3, 4, 5, 6, 7, 8. And it's going to keep going to the left with y being 2. Okay, now for the second one, notice we have here an absolute value function. So we definitely want to include our beginning and our end point. And then we also want to include our vertex. Remember the vertex from last time. You have h minus k, or x, scratch that. You had x minus h plus k. So our vertex would be negative 1, 5. So we're going to put that in here also, because it's important to know where our v forms. And then let's see what our two endpoints are. If x is negative 8, you'd have negative 8 plus 1, which is negative 7. Absolute value is 7 minus 5 is 2. And then if x is 6, you'd have 6 plus 1, which is 7. And 7 minus 5 is also 2. So if x is negative 8, now notice here we have an open circle because it's not equal to, it's only less than. So at negative 8, 2, we put an open circle, which it actually already has a circle there, or a dot there, so we really didn't need anything. But if there hadn't have been something there, we would put the open circle. And then negative 1, 5. So 1, 2, it's actually negative 5. So negative 1, 1, 2, 3, 4, 5. Because this is negative there, so that's why that should have been negative. And then 6, 2. 1, 2, 3, 4, 5, 6, 2. And here we do put a closed circle because it said less than or equal to. And then we can connect those points to form our V. And then let's look at the last part. We know that's a linear function. So we'll start with the 6 that it gives us. If x is 6, 6 times 3 is 18, minus 6 is 2. So 6, 2, which we already have filled in, and that would actually need to be an open circle if we hadn't already had something there, but it is already a dot, so it stays. And then since it's as a line, we can look at our slope here, 3 over 1. So up 3, 1, 2, 3 over 1, up 3, 1, 2, 3 over 1, and there are some points to draw our line. And just to show you what the entire graph should look like, all with one color, we have going from here, that way, comes down to here, back up to here, and there. Now this piece function, our 3 pieces happen to touch. They don't always connect like that. So this one would be considered a continuous graph. Sometimes they would be discontinuous. Now let's look at our domain and our range. Our domain is our x values. If you look at this, you notice it keeps going to the left, it keeps going to the right. It's already hit all the points in between the two arrows, so your domain is all real numbers. Now your range, it does continue going up right here, but it stops at this point, and that point is -1, 2, 3, 4, 5. The value there is -5. So your range is y is greater than or equal to -5. Now this last graph is another type of piece function, but it's also what we call the greatest integer function. What we're going to do is we're just going to pick several values for our XY table. You want to pick some integers and fractions so that you can see what's doing here. So let's say, for example, from -2, -1.5, -1, -0.5, 1, 0.5, 1.5. Let's change that to 1.5 and 2. Let's look at those. So if x is -2, we can leave that as a -2. So let's actually do it this way. So you would have 2 times -2 plus 1, which would be -3. If x is -1.5, we have to go to the integer that is less than or equal to. So that would also be -2. So that's still going to be -3. If x is -1, you have 2 times -1 plus 1. So that would be -2 plus 1, which is -1. If you have -0.5, you're also going to use -1 because that's the closest one to the left. And that's the one that's less than or equal. And so that's also going to give you -1. Then if you have 1, it'd be 2 times 1 plus 1, which would be 3. 1.5 is also going to be 2 times 1 plus 1, which is 3. And then 2 would be 2 times 2 plus 1, which is 5. So if x is -2, y is -3. And if x is -1.5, it's -3. And if x is -1, then y is -1. Up here, -1/2. We didn't do 0, but if x were 0, it would be right here. And if x were 1/2, it'd be right there. So you can start to see, and we're going to do a closed circle because all the way up to this point, it's going to be here. So we end these lines with a closed circle. And it's basically going to keep continuing in this pattern. And this is how your greatest integer function always looks. It just may move around and it may shift based on what's being added or multiplied to the greatest integer. Put that back in there. So just continue this pattern all the way to the top and bottom of your graph, and that's your greatest integer function. Now, your domain that'll be your x values. It keeps going left to right and covers everything. So that would be all real numbers. Now your range, if that 2 wasn't there, it would be all your integers. But since it is, notice it's every other integer. we've got a y at -1, at 1, at 2, or not 2, at 3, at 5, at 7, at -1, so your range, we want all of our odd numbers, negative and positive. So we can't possibly list all of them. So we know they keep going to the left on our number line and they keep going to the right. So we'll start with dot, dot, dot. And then you could say -3, -1, 0, 1, 3. They keep going this way also. Dot, dot, dot. So that would be your range.